your Golf Delta Yankee crossing the motorway.
Golf Delta Yankees cleared land runway 04, surface wind 05, degrees 15 knots.
Cleared land runway 04, Golf Delta Yankee.
Congratulations, that completes the final flight test for your private pilot's license.
Almost anyone from the age of 17 years onwards has the ability to become a pilot. The purpose of this video is to show you the main exercises that you will practice in the gaining of your private pilot's license. In addition, I hope you will glimpse a sense of the fun and a sense of the freedom that only a pilot knows. We'll show you a first solo, and we'll even follow a short cross-country navigation exercise. You'll see what is required for the ground examinations. And at the end of this video, we will take a look at some of the goods that are available for the private pilot to purchase. So, let's start with a look at the controls.
This is the cockpit. At first sight, the cockpit may look confusing, but in reality, it's no more complex than a sophisticated motor car. Here we have the airspeed indicator. This shows us how fast we're travelling through the air. The artificial horizon for orientation without reference to the visual horizon. The altimeter, which shows us our height or altitude. The direction indicator, showing magnetic compass heading. The vertical speed indicator giving rate of climb and rate of descent. The turn coordinator, which shows us roll, yaw and balance where the air flows evenly about the fuselage. Down here, the engine gauges indicating oil pressure, temperature and engine functions. And here the throttle quadrant. The throttle, the mixture lever, the carburetor heat control. And this is the parking brake in the on position. And these are the aircraft radios for communication and navigation. And this the RPM or power gauge. Down here, the electrical switches for such things as lights and fuel pumps. This is the fuel selector with two tanks, the right tank and the left tank. And here the flap selector. Here the trim wheel, used to relieve control column pressures during flight. The control column. Movement of the control column towards you will cause the elevator to go up, the nose of the aircraft to pitch up. Movement of the control column forward causes the elevator to go down, for the nose of the aircraft to pitch down. Rotation of the control column to the left causes the left aileron to go up, the right aileron to go down, and for the aircraft to roll, then yaw to the left, followed by spiral dive to the left. Rotation to the right causes the left aileron to go down, right aileron to go up, and for the aircraft to roll, yaw, and spiral dive to the right. For balanced flight, the rudder pedals. Movement of the pedal to the right causes the nose of the aircraft to yaw to the right, roll to the right, followed by spiral dive to the right. Movement of the pedal to the left causes the rudder to move to the left, followed by yaw to the left, roll to the left, and spiral dive to the left. The flaps. The flaps are used to alter the lift and drag generating abilities of the wings. The trim wheel, used by the pilot to relieve control column forces. By moving the trim wheel forwards or aft, the pressures on the control column can be reduced to 0. And now the throttle quadrant. The throttle. More power, throttle open. Less power, throttle closed. The mixture lever. More fuel, mixture rich. Less fuel, mixture lean, and no fuel, the idle cutoff position. The carburetor heat control. Ice can be prevented or eliminated by raising the temperature of the air entering the carburetor venturi with the carburetor heat. Hot and cold. So let's see how these controls affect the aircraft's movement in flight. Movement of the elevator will cause the aircraft to pitch, nose down, nose up, about the aircraft's lateral axis. Movement of the ailerons will cause the aircraft to roll, wing left, wing right, about the aircraft's longitudinal axis. And movement of the aircraft's rudder will cause the aircraft to yaw, left and right, about the aircraft's vertical axis.
Okay, well here we are airborne. Let's now have a look at the effects of the controls in the aircraft. First of all, the elevator. I'm now going to move the control column forward, and you'll see relative to the horizon, the nose pitches down, the horizon climbs up in the windscreen. We see a loss in height and a gain in speed. No secondary effect, no change in direction. I now move the control column towards me, and you can see the nose pitching up, up and up, horizon low in the windscreen. The aircraft gains height and loses speed, but no change in direction, no secondary effect. Let's now look at the ailerons. I'm going to rotate the control column to the right. You'll see the right wing go down, the left wing go up, and you can see the horizon is no longer level in the windscreen. However, in addition to the roll, we can see that the aircraft is yawing to the right. And if I relax the back pressure on the control column, the nose pitches down, and the aircraft enters what we describe as a spiral descent, losing height, gaining speed. And of course, the same will occur when I rotate the control column to the left. To bring the wings level, control column left, and there we are, wings level again. Let's now look at the effects of the rudder. I'm now going to press the left rudder pedal. Check that we're clear first of all. So left rudder pedal, you can see the nose yaws to the left, the aircraft rolls to the left, and eventually enters the spiral dive to the left. And the same will occur when I press the right rudder pedal. Wings level now, and there we are, returned again to straight and level. Let's now have a look at the effects of power. I'm now going to increase to full power, and note what happens to the nose position relative to the horizon. Here we go. Full power is being applied. Note the nose of the aircraft pitches up and yaws and rolls to the left. Returning the aircraft back to straight and level flight, we'll then have a look at what happens when we reduce the power. So here we are again, straight and level. I'm going to reduce the power. Note the nose of the aircraft pitches down, yaws and rolls to the right, and recovering back to straight and level flight. Good, so that's the effects of the power. And now on this aircraft, let's have a look at the effects of flap. Here we are again, straight and level 2,000 feet within the flap limiting range. I'm selecting one stage of flap, and note what happens to the nose of the aircraft. 1, 2, 3, a very abrupt change in attitude, nose pitches up. Returning the aircraft back to straight and level flight. 2,200 feet. What happens when I reduce the flap? Flap now going up, 1, 2, 3, and likewise the nose pitches down. So when we change power, or when we change the flap position, we must be aware of what effect this has on the aircraft, be ready for it, and move the